A DC motor is made of 110 rectangular coils, each of length 100 millimeters and breadth 75 millimeters. This will be important later on, don't worry. The plane of the coil is at right angles to a uniform radial magnetic field, bit of a mouthful, of 300 millitesla. So a millitesla is 10 to the minus 3 teslas. Determine the torque on the coil when a 7 amp current flows through it. Torque. I hope you can remember the equation for torque. It is, of course, torque equals NBIA cosine of theta. So because we have a radial magnetic field, we're always going to have the maximum value for cosine theta, so we can ignore it. It'll just evaluate to 1. So what else do we have? We have the current, so that's I. We have the magnetic field strength, so that's B. And we have the number of turns, so that's N. What we don't have is A, the area. But of course we can figure that out because we have the dimensions of the coil. Now it's very important here to convert these numbers into meters before we use them in the equation. Why is that? Well, it's because 1 millimeter squared is not the same, or rather 10 millimeters squared is not the same as 10 to the minus 2 meters squared. We have a problem here. Similarly, 1 millimeter squared is not the same as 10 to the minus 3 meters squared. These are two very different numbers. In fact, if we take 1 millimeter and we square it, we'll have 10 to the minus 3 meters times 10 to the minus 3 meters. And you can see, of course, that this will be 10 to the minus 6 meters squared. And so because of this, it's a lot easier, instead of working in millimeters, to just make sure everything is in meters before you start multiplying things together. Right? We can see that for cubic meters, there's going to be an even greater discrepancy. And in fact, if we want a conversion for cubic meters, it'll be an even bigger change. 1 millimeter cubed will equal 1 billionth of a cubic meter. So it's important to remember how units work when we're squaring them. All right, with that out of the way, let's actually do the substitution. We have 110 for the number of turns in the coil, 0.3 because we've converted our millitesla to Tesla, 7 for the current, I, and our area is going to be 100 millimeters times 0.075 meters, which is 75 millimeters. And of course, the cosine will just be the maximum value. So our answer here is 1.73 Newton meters. Don't forget the units for torque, they're a little bit odd.